Next segment that we have, or next item in solids that we have, is pyramid. Okay, so let's try to understand the pyramids. Pyramids are a solid structure in which we have one base and a vertex, right? Vertex at a distance. What does that mean? Let's take an example. If I take a circular base and just opposite to the center, somewhere at a distance, I take another point. So this becomes my vertex. And then I join every point on the circle with this point. What I'm going to get? I'm going to get cone. So cone is circle base pyramid. Okay? Circle base pyramid. Just try to remember that. For example, if I take a square base and I take a point somewhere at the exactly opposite the point of intersection of diagonals and join all the corners of the square, you see I get a square base pyramid, right? Fine, simple. If I take a triangle, right, and I take the circumcenter of this and I join a vertex here, join all the vertices of this triangle with this vertex. So this is a triangle base pyramid. Okay. So this is the general cone that you must have seen. If this is the if this is an equilateral triangle on all sides, then this structure will be the structure of methane. Those who have gone to school in science, 12th standard, you would have studied. Don't worry about it. Yeah, it's just a recall for some of you. If you don't know, don't worry about it. Try to imagine. I always try to write things and draw things because that is the only thing that is going to help you in the exam. In the exam, you don't have perfect drawing tools. So you should be really habituated in studying a hand-drawn diagram, and you should be able to draw them on your own whenever necessary. Okay. Now for pyramids, what are the formulae that we need to know and remember? Let's try to understand that. So in pyramid, we'll focus only on cone. Okay. So in general, the volume of pyramids is given as 1/3 into base area into height. Okay. So for cone, it will be 1/3. Base area is pi r square because it is circle into the height. Remember, if I draw it again, this is the circular base. This is the, this is the radius. This is the height, and this is the slant height. This L is the slant height. Okay. So volume is 1/3 pi r square h. Now this L, h and r, they are related through the right angle triangle. So L is equal to square root of r square plus h square, obviously. Now this is important because the next thing that we have is the surface area. And here it becomes a little crucial and important to memorize. So base area, total surface area will have two components in this also. Base area plus lateral area. Or in this case, the lateral area will be called curved surface area, CSA. It will be called curved surface area. Okay. Now the base area is pi r square, right? And curved surface area is actually calculated with the help of integration, but you just remember it is pi r L, right? So the total surface area will be equal to pi r square plus pi r L, or pi r into r plus L. And this is the total surface area of cone, right? So we have volume, we have total surface area, we have lateral surface area, and the relation of slant height with radius and height. Fine. Now there is one very important thing that actually you should directly know, which is slightly scary also. Okay. It is known as a frustum. Okay. What happens if I cut a cone parallel to its base? Okay. If I cut a cone parallel to its base, let's say if I cut it here, what do I get? After cutting it, what I get is this thing. I'm removing this whole thing, right? I will get a plane surface here as well. Now this is a circular surface, this top is also a circular surface, but the radius is different. So let's call this radius as R1 and this as R2, right? So this structure is the frustum structure. It looks like bucket or a hat, something like that, right? For frustum, so frustum is a, now let me draw as dotted lines. It's a cut part of a cone only, right? So we should not get into the details of this. We should just remember it. The volume of frustum is given as 1 by 3 pi R1 square plus R2 square plus R1 R2 into H. Here I am using capital H because this length is capital H. It is the distance between those two parallel surfaces. It's not very difficult to remember. See, here R square is degree 2 term. Here R1 square, R2 square is degree 2. R1, R2 is also degree 2. The combination of both R1, R2. Okay. Okay. So this is the volume of frustum. Just remember this capital H is the distance between those two parallel circular surfaces. And this is the volume of only the frustum. Okay. Now, let's call this length as capital L. This is the slant height of the frustum, not the original cone. Okay. Slant height of frustum. Fine. You can drop a perpendicular from here, and from, if this length is H, this is also H. From here you can find the relation of L, H and R1, R2. I'll just write it here. L is equal to square root of R1 minus R2 whole square plus H square. Simple Pythagoras theorem. Right? Now why do I need this? Because for surface area here, if I want to calculate total surface area of a frustum, okay, this will be equal to, again, curve surface area plus the bases. Bases are very easy to understand because it is pi R1 square plus pi R2 square. So pi R1 square plus R2 square. The curve surface area is given as, for original cone, it is pi RL. For frustum, it will be pi R1 plus R2 into capital L. And this is the total surface area. Fine. You just need to memorize this. Right. So we have done cone.